let's please continue from where we left off last night. This is what we looked at yesterday in terms of using the second derivatives to find maximum and minimum values and sketching the graph. I'm just repeating what we talked about and did yesterday. When given a function and required to find the relative extrema of the function, we said we first find the first derivative and we also find the second derivative. From the first derivative, we get the critical points. Then we also get the corresponding points, y values, for those critical points. How do we get those values? We substitute in the original equation, not into the first derivative equation or the second derivative equation. Then to get the relative maximum and relative minimum, we apply this theorem where, number one, when the second derivative of c is greater than 0, that function is said to be having a relative minimum. But when the second derivative of c is less than 0, the function is said to be having relative maximum. Then, when the second derivative of c is equals to 0, we say the first derivative test can be used to determine whether the function is a relative extrema or not. This is what we did. We're given this function, found the first derivative, and also the second derivative. From the first derivative, we got the critical points. From the critical points, then we got the corresponding y values. F of minus 3 in the original equation, we got it to be 14. F of 1 into the original equation, it gave us 12. Using this theorem, where the second derivative of c is greater than 0, in this case, being 12, this function has got a relative minimum. F of minus 3 is giving us minus 12. Therefore, that's why we are saying this function has a relative maximum. Then, we then plotted these corresponding points and then ended up having this function. Okay, if there is no question based on what I just said, because this is what we spent much time on yesterday. Now, doing what was done in this example, I'm requesting you then to find the relative extrema of the function f given by f of x, which is equals to 3x to the power 5 minus 20x to the power 3, and sketch the graph. We do exactly as we did in example 1. What did you get to be the critical values?
Critical values were 0, 2, and negative 2.
You say the critical values were?
0, 2, and negative 2.
0, 2, and negative 2. Okay. And then what did you find to be the relative minimum and the relative maximum?
I don't know if I'm correct.
This time, Zwanga, are you not writing on Monday?
I'm writing on Monday. It's
So
I
you
said
should be
64
sure.
and negative 64.
Relative minimum?
Negative 64.
Negative 64. And relative maximum?
64. Positive 64.
Positive 64. And then what did you get to be the corresponding Y values for those critical values?
Oh.
Remember from the first derivative, we get the critical values.
Yes.
We then take those critical values, we substitute into the original equation to get the corresponding Y values.
I did things the other way around because I think my Y values are positive and negative 64. And then I've got 240 for my relative and maximum, minimum and maximum.
Okay, let me rephrase my question to you in this way, Zonga. What did you get the corresponding Y value for 0? You said the critical points are 0, positive 2, and negative 2. Okay? Then, what is the corresponding Y value for 0?
It's 0. It's 0.
Yes, it's 0.
Sorry?
It's 0.
It's 0. Okay? Then, the corresponding Y value for positive 2?
Negative 64.
Negative 64.
Negative 64. The
Yes.
corresponding Y value for negative 2?
Positive 64.
Positive 64. Finally, please, let's confirm something, you and I. You said, what is the relative maximum?
240.
The relative maximum, or are you saying the relative maximum is 240?
Yeah, but I stand to be corrected.
All right. What is the relative minimum?
Oh, it's 2 and negative 64. So me, I don't know.
Okay. Zwanga, what are you saying?
I did calculations. Please assist.
Okay,
Family members.
Don't confuse these things. Okay. Let me say, what is the relative maximum?
Gonna be minus.
Ulufelo?
I was thinking minus 2 and 64.
Minus 2 and 64.
Yeah.
And, all right. And the relative minimum?
It's gonna be the 2 and minus 64.
Okay. Please stick to those values that you just gave me. Nah?
Yes.
On the critical values, that we seem to be in agreement, because the critical values are 0, 0, negative 2, and positive 2. Okay,
Yes.
these are the critical values. Then the corresponding y values. We take this negative 2, we substitute in the original equation, this equation. Then the corresponding y value is 64. Is this what you got?
Yes, sir.
And then, now when we substitute 0, you said the corresponding y value is 0. Ne? This is what you said.
Yes. Yes.
And then you said f of negative f of 2, when we substitute 2 into the original equation, did you say you got negative 64?
Yes.
Thank you. Then the next thing that we need is to find the second derivative. This is the second derivative from the original equation. Then from there, we take those values of the critical values, we substitute into the second derivative. Now, when we substitute minus 2 into the second derivative, we get negative 24, which is less than 0. This shows that this negative 240 is the relative maximum.
Oh.
And then, from this theorem, it's not me, it's this theorem. Please.
Yes, sir.
Where were we? Okay, we were here. And then f of should be here. F of 0 is 0. The second derivative test fails. Use the first derivative test. But f, the second derivative, when we substitute 2 into the second derivative, we get positive 240, which is greater than 0. This tells us that this is the relative minimum. Therefore, this curve of ours has got the intervals from the critical points. From these critical points, meaning, remember I said, from the critical points, then you form intervals. Do you remember? Did you forget? Hello? Were you all here yesterday?
No.
Yeah. Zwanga, I think you were here yesterday. Zwanga.
Yes, but I was having connection issues yesterday, so I wasn't able to be clued in.
All right, no problem. Then from the critical values, then you form, hello?
Yes, Praklen Mandla here. I was here yesterday.
Oh, thank you, Mr. Mandla. How are you?
I'm coping, and yourself?
Let's just hang in. Let's just hang in there. Tomorrow, I mean, Monday is the day. Only one day left. So, I said, after getting the critical values, from the critical values, then you form intervals. Critical values are 0, -2, and +2. Now, it doesn't matter where you start, but the interval, let's say for -2, it will be from negative infinity to negative 2. Okay? And then from there, another interval will be from negative 2 another interval will be formed by negative 2 and 0. And another one will be formed by 0 and
0 and 2.
positive 0 and 2. And another one will be formed by positive 2 and positive infinity. Do we agree?
Yes,
This
yes,
is
agree,
what-
agree.
Thank you. This is what I said yesterday. Then we'll have to take all those points that we calculated and then put them in here. Then, after forming the intervals, you will then, from the intervals, you develop a table of signs. In an interval, you choose one number, and then you substitute into the second derivative to get the sign for the second derivative. If the number that you get is less than 0, that means that the function or the graph in that interval is decreasing. But if the number that you chose in that interval is positive, that means that the function or the graph in that interval is increasing. Like in this case, the interval will be between negative infinity and negative 2. And therefore, as you can see from here, it is telling us that from that table of sign, if you drew it, then it will show you that when you choose any number between negative infinity and negative 2, that means, and substitute into the second derivative, you will get a positive number. That's why this function is said to be increasing. And then between negative 2 and 0, when you choose a number between negative 2 and 0 and substitute into the second derivative, that means the number that you get is negative. Therefore, that second derivative is less than 0. That is why it's said to be decreasing here. Here. Over this interval and this interval. And then the point that we got, okay, let me finish this. Then another interval was between 0 and positive 2. In here, when you choose a number and you substitute it into the second derivative, then you will see that that number that you get is negative. That's why they're saying the function is decreasing. But from on the interval, in the interval between 2 and positive infinity, if you take any number and substitute into the second derivative, then you will get a positive number which is greater than 0. That's why the function is said to be increasing. And then that will also guide you in terms of how to plot the function. Remember, these are the values that you got. These are the values that you got. These are the values that you got. You would have found this from that table of sign. This is what we did yesterday. Do we agree? Or do we disagree? Members, are we together?
Yes, yes, we're still together, Berkeley.
Thank you. Now, let's move forward and talk about inflection points or points of inflection. Please, let's start here. Points of inflection. They say, look again at the graphs in examples 1 and 2. This is the graph. This is the graph. These are the graphs that they are referring to. The concavity changes from down to up. The concavity changes from down to up at -1 and -2. Which one is that? -1 and -2. This is what they are referring to. This one. The concavity changes from down. Okay. The concavity changes from down to up at the point -1 and -2 in example 1. This example 1. Concavity changes from down to up. Changes at this point from down to up. And the concavity changes from up to down at the point 0, 0 in example 2, 0, 0. The concavity changes from up to down, meaning from here, the graph continues to go down at 0, 0 in this example. A point of inflection or an inflection point is a point across which the direction of concavity changes. For example, in figures 1 to 3, these are the figures. Point P is an inflection point. P, this P, this P is an inflection point in all these figures. The figures display the sign of the second derivative of F to indicate the concavity on each side of point P. Let's look at this figure. On this side, it's going up, it comes down, it decreases, that's why this negative sign. Then it goes down, then it goes up. That's why this positive sign. Then here, down before P. Then tends to increase. Here it's increasing, then it's coming down. Then from here, let's talk about this theorem. Finding points of inflection. If a function f has a point of inflection, it must occur at a point x sub 0, where the second derivative of x sub 0 equals to 0, or where the second derivative of f of x sub 0 does not exist. Now, let's look at this next example. In this example, what are they saying? They say, use the second derivative to determine the points of inflection for the function in example 2, the example that you worked on. What is it they're looking for? They say, use the second derivative to determine the points of inflection for the function in example 2. The function is f of x equals to 3x to the power 5 minus 20x cubed, and its second derivative is 60x cubed minus 120x. We set the second derivative to be equals to 0 and solve for x. When we do that, we get x to be 0 minus the square root of 2 and positive the root of 2. Next, we check the sign for the second derivative of x over the intervals bounded by these three values, 0, negative root 2, and positive root 2. This interval, this one, the interval is minus infinity and minus root 2. The interval over here is minus root 2 and 0. Over here is 0 and root 2. Here is root 2 and positive infinity. Then, Tirampoli.
Yes, sir.
Yes.
May
I'm
you please
listening.
scroll down a little bit? I just want to take a screenshot. So I meant up, sorry.
Please tell me where to stop, eh?
Okay, sir. You can stop. Thank you.
Are you done?
Yes, sir.
Okay. Thank you. Okay, then over these intervals, you choose a number and substitute into the second derivative test. In this case, the test value or the number that was chosen was -2. Then it gave a negative number. That's why they say it's less than 0. Between negative root 2 and 0, -1 was chosen. It gave a positive number. That's why they say it's greater than 0. Between 0 and root 2, 1 was chosen and substituted into the second derivative. And then it gave a negative number, which is less than 0. Between positive root 2 and positive infinity 2 was chosen, and then it gave a positive number, which is greater than 0. That's why they are saying here, when it's less than 0, they're saying the curve is concave down. When it's greater than 0, it's concave up. When it's less than 0, it's concave down. When it's greater than 0, it's concave up. That is why it's important to have this table of signs to see how the graph is behaving. All right. These are the critical values. Then their corresponding y values will have to be found. So, negative root 2, substitute in the original equation to get the corresponding y value. 0 in the original equation to get the corresponding y value. Root 2, that's why they wrote f of f of. Looking for the corresponding y values. Now they are saying f of negative square root of 2 is 28 root 2. And f of 0, the corresponding y value is 0. F of the square root of 2, the corresponding y value is negative 28 root 2. Therefore, that's why they say these are the points shown on the graph. 0, 0. This will be the negative 1, or this is the one. And this one will be this one. Are you still with me? Thank you. Now, let's talk about this, because everything here they are summarizing what we have been doing. Curve sketching. The first and second derivatives enhance our ability to sketch the curves. We use the following strategy. Number A, derivatives and domain. Find the first derivative and the second derivative. Note the domain of f. Critical values of f. Find the critical values by solving the first derivative of x, putting it to be equals to 0, and finding where the first derivative does not exist, meaning putting it to equals to 0. These numbers yield candidates for relative maxima or minima. Find the function values at these points. Number C, increasing and or decreasing relative extrema. Substitute each critical value from step B into the second derivative. If the second derivative is less than 0, then function is a relative maximum. And f is increasing to the left of x sub 0 and decreasing to the right. If the second derivative is greater than 0, then f sub 0 is the relative minimum, and f is decreasing to the left of x sub 0 and increasing to the right. Inflection points. Determine candidates for inflection points by finding where the second derivative equals to 0, or where the second derivative of f does not exist. Find the values, the function values at these points. Concavity, use the candidates for inflection points from step D to define intervals. Substitute test values into the second derivative to determine where the graph is concave up and where is concave down. Here they are referring to that table of signs that we need to draw. And then finally, sketch the graph. Sketch the graph using the information from steps A to E, calculating and plotting extra points as needed. Are we together? Members, do you follow? Hello.
Yes, yes, well, yeah, maybe it will be clear with examples, Bratlan.
Okay. Now, where should I go? I'm now going here. Exercise set 2.2. Where are my questions? Here are my questions. Sketch. Sketch. I'm here. Sketch the graph of each function. List the coordinates of where the extrema or points of inflection occur. State where the function is increasing or decreasing, as well as where it is concave up or concave down. Sorry. The first one, number 9. How many minutes do you need to work out number 9? Number 9, this one. F of x equals to x cubed minus 12x. You do exactly what we have been doing. Hello.
Do we have to draw the graph as well?
Chiramboni. Here,
Yes, sir.
here it says sketch the graph of each function. List the
Okay.
coordinates of where extrema or points of inflection occur. State where the function is increasing or decreasing, as well as where it is concave up or concave down. This you will get from the table of signs.
Thank you, sir. I didn't read the question.
Oh, okay, thank you. Then, how many minutes are you giving us, Ms. Ramboni, to work out number 9?
Sir, I think 4 minutes is enough.
Okay. Members, Ms. Ramboni says 4 minutes should be enough. Thank you.
Yeah, I think I can say I'm done. Yeah.
Are you done? Okay. Then, what are others saying?
I am not done, but I think I'm doing something wrong.
Hmm?
I'm still busy, but I think I'm doing something wrong because I'm struggling to sketch the graph.
Who's talking?
Tirampon.
Tiramboni, you say you think there is something that is not making sense
Yes, sir.
because you are unable to sketch the graph.
Yeah, I think my graph is wrong.
Who said so?
It's my mind.
Is your mind? Huh. All right. Now, I hear you. And then it is important to listen to your mind at other points in time. Someone said it's done. Mr. Mandla, are you the one who said you are done?
Yeah. I'm the one who said I think I'm done. Yes.
Oh, okay. Now, please, let's start here, you and I. That's
Yes.
number 9, eh?
Mm.
Let's start here. What are the critical values?
Okay, so for the critical values, I got 2 and -2.
Ms. Tiramboni, what are your critical values?
I also got the same critical values.
Okay. Zwanga, what are your critical values?
I also got 2 and -2.
Thank you. At least there is an agreement. Then, now, my next question reads as follows. From okay, let me just say it in this way. What did you get as the relative? Let me start with minimum. What did you get to be the relative minimum? We agree on the critical values. I'm also in agreement with what you said, 2 and -2. What is the relative minimum that you got?
-16 is a relative minimum. Stand to be corrected, family members.
Okay, let me rephrase my question. We agree about the critical values. Now, we agree that the critical values are x equals to 2 and x equals to -2. When you substitute
I hear
in
your
the
question.
original equation, what are the corresponding y values that you get?
Okay, the relative minimum will be x at 2, and then y will be -16, and then
Thank
relative
you.
maximum.
I agree with that. Let's check whether family members agree. Mr. Ramboni, Zwanga, do you agree with what Mr. Mandla has just said? Tiramboni agrees, Zwanga agrees. Okay, Mr. Mandla, please proceed. Relative maximum.
All right, and then the relative maximum will be -2, corresponding with y of 16, positive 16.
Thank you. Members, Tiramboni, Zwanga, do you agree? There seems to be an agreement. And then, now we are done with relative minimum and relative maximum. The next thing that we need are the inflection points. Remember, they can be 1, they can be 2, they can be 3, they can be 4. So now, what is the inflection point that you got? Inflection point, where is it?
Yeah, Braglen, here I'm sharing the mic. Yeah, someone else can speak. Yeah.
Tiramboni, thank you, Mr. Mandla.
Got x at 0 equals 0. So the point of inflection is at 0.
0
at the origin.
and 0. It's at the origin where x is 0 and y is 0. Is
Yes,
that what you are
sir.
saying, Mr. Tiramboni? Ms. Tiramboni?
Yes, sir.
Thank you. I agree. Is there anyone who is saying something different? Do we agree? The inflection point, there is only one inflection point at the point where x is 0 and y is 0. Now, Ms. Tiramboni,
Yes,
or
sir.
maybe let me go to Zwanga. Zwanga,
Sir,
please help out here. What are the intervals? The intervals, what are they?
I didn't get that far.
Didn't get it?
No.
Zwanga, it's important to have the intervals so that you can be able to see. So it's important to have the intervals so that you can be able to have that table of signs, so that you can be able to see where the graph is concave up and where the graph is concave down. Mr. Ramponi,
Yes, sir.
please, let's talk. What are the intervals that
I
you
cannot
got?
calculate the intervals. I think that's why I was struggling to sketch.
Okay, thank you. Let me go to Mr. Mandla. Mr. Mandla,
Yes, sir.
my brother, what are the
Yes.
intervals before we go any further?
Yeah, so the intervals, Braglen, because we have x equals to 2 and x equals to minus 2, the intervals will be negative infinity to negative 2. Then the second one will be negative 2 to 2, and then 2 to positive infinity.
I clearly agree. Mr. Ramboni, did you hear that?
Yes, sir.
If you have got those intervals, there is no way that you won't be able to draw a graph, taking into account those points that you already have.
Okay, sir.
And they will guide you. Now, let me go back to Mr. Mandla. Mr. Mandla, please help me out, help us out here. Over the interval minus infinity and minus 2, is this graph increasing or decreasing?
Between negative infinity and minus 2, it's increasing.
I agree with you. And now, between minus 2 and 2, what is happening there?
According to the first derivative, it's decreasing.
Decreasing. Okay, concave. Okay, I see, decreasing. Then, help out here. Over the interval, 2 and positive infinity.
It's increasing again. It turns
Increasing.
and increases.
Yes, I agree with you. Now, let's talk. Mr. Ramboni,
Yes, sir.
did you hear what we just talked about?
Yes, sir.
About the intervals, where the graph is increasing, where it's decreasing. Where, when we say it's increasing, we're saying it's concave up. When we say it's decreasing, we mean using the second derivative test is concave down. That is what we mean, eh?
Yes, sir.
All right. Now, Mr. Mandla.
Sir, can I quickly ask a question?
Yes, my sister.
So when we write the intervals, do we include everything, or is it just negative infinity less than x less than negative 2? Or is it less than or equal to? Do we include it or exclude it?
Okay. That's Mr. Ramboni, né?
Yes, sir.
Okay. Let me help you out, my sister. Let's go back here. This is what we talked about yesterday. I'll use this example. I'll use this example. Okay? This is what we looked at yesterday. They asked us to graph the function and find the relative extrema. What did we do? We first had to find the first derivative, okay? Here, all right? Are you with me?
Yes, sir.
We had to find the first derivative of this function. This is the function, this is its first derivative. Then, we then had to put the first derivative to be equals to 0 to get the critical values. Okay? Then we got the critical values to be -1 and 2. All right? Are you with me?
Yes, sir, I'm with you.
Then, please read this for me. What have this paragraph that I've highlighted? Please read it for me.
The critical values are -1 and 2. Since it is at these values that a relative maximum or minimum might exist, we examine the intervals on each side of the critical values. A is not there, so they're not included. So I don't understand what I just read.
Yeah, please continue to read. Then I'll.
Okay, A is in the interval of -∞ to -1. B is -1 to -2. And C is from 2 to infinity, as shown below.
All right. My sister, after getting the critical values, né,
Yes, sir.
you need to have the intervals. You get the intervals from the critical values. Okay. This is, they're saying here, A, or the first interval. Do you remember a number line?
Yes, sir.
In primary, grade 1, sub A, you remember?
Yes, I remember.
That's where this whole thing is coming from. Remember, at the center of the number line, there is a number there. What is that number? At the center.
0.
0. Yes. 0. To the right of 0, which numbers are we having?
To the right, we have positive numbers.
Thank you. Because you and I are right-handed. I thought I would have a challenge. I would have a challenge if you are left-handed. Now, to the left of 0?
Negative numbers.
Negative numbers. Now, please, let's come here to this. Do you see this interval? This one? You
Yes,
see this
sir.
one?
I
The
see it,
critical
sir.
value. Yes, the critical values are -1 and 2. So now we have to form intervals from the critical values. Sorry. Now, we have got -1. Meaning we have been traveling from the far left, to get to -1. Okay?
Yes, sir.
We are coming from the far left to -1. Where are we coming from? Are we not coming from -infinity?
We are.
Now, is this -infinity making sense? Why is here?
Yes, sir.
Okay. This is the first interval, -infinity and -1. Okay. This one, I think it does make sense now to you how it came about.
Yes, sir.
Now, still on the number line, look at it from a number line. Then another interval is -1 and 2. We are having -1 and 2. Remember? So another interval is -1 and 2. Do we agree?
Yes, sir.
The next interval now is 2 and positive infinity. Is it making sense?
Yes. Thank you, sir.
Then from there, this is the interval. This is the interval from -1 to -1. Here is another interval, -1 and 2. Here is another interval from 2 to positive infinity. We are not done. Then we come here. We need to have this table. Oh, they repeated it here, the interval, okay? Negative infinity to -1, -1 to 2, 2 to positive infinity. It's clear to you now. Now the next thing that you need, you need to have this table. You see this table?
I see it, sir.
Ideally, the way I prefer to draw it, I prefer to have this interval at the top, okay?
Okay, sir.
But let me just take you through it the way they drew it. The most important thing is for you to can be able to understand what you are doing. Now, this is what they are saying. Between negative infinity and -1, you choose any number between negative infinity and -1, okay?
Yes,
So
sir.
that's why they say test value. They chose -2, okay? They substituted it where? In the first derivative. -2, they substituted in the first derivative. Here, see? First derivative of 2. What is it that it gave them?
24.
Positive 24. Now, they then came here, but this is for the first derivative. Don't get confused. Then they are saying, we substituted -2 in the first derivative of this function. And then we got a number that is greater than 0. That number is 24. That number is greater than 0. That is why they are saying this number that they got when they substituted -2 in the first derivative is greater than 0. They are referring to this 24. Are you with me?
Yes, sir.
Then, the next thing that they did, they chose the number and the interval that they also had in this case was -1 and 2. And then they chose 0, okay?
Yes, sir.
They took the 0 and substituted where? In the first derivative. And then they got -12. And then they got -12, -12 is less than 0. That's where this is coming from. That's why they wrote it the way they did.
Sir, may I
It's
ask a question quickly?
Yes.
So in order to know the interval, do you substitute it into the first derivative and not the original formula?
Okay. Please, I almost said something, but I don't want to confuse you. Please repeat your question.
So when we want to know the intervals, whether they're increasing or decreasing, we substitute the number that we chose, do we substitute it into the first derivative and not into the original formula?
Yes.
Okay, so that's what I wasn't understanding.
Remember, you get the critical values, né?
Yes, sir.
To get the corresponding y values, you substitute those critical values where in the original equation to get the corresponding y values. Okay?
Yes, sir.
But to show the behavior of the curve over the interval, or how it will behave when you draw it over the points that you already calculated, You substitute in this case, because this question was dealing with the first derivative, okay? So then you choose a number between the interval. You see, here they said, okay, a number between negative infinity and negative 1. They chose negative 2 and substituted, and then they got positive 24. Then that number is greater than 0. That's why they are saying f is increasing. That's where this conclusion is coming from on this interval. And then on this interval, negative 1 and 2, they chose a number which is between negative 1 and 2, which is 0. They substituted in the first derivative. They got negative 12. Negative 12 is less than 0. Now, that number being negative 12, which is less than 0, that shows that the function is decreasing on this interval. Mr. Rambo, still with me?
Yes, sir.
Then, on the last interval, which is 2 and positive infinity, they chose a number. In this case, they chose 4. And they substituted it where? In the first derivative. They got positive 60. Positive 60 is greater than 0. Then they said, when we substitute 4 in the first derivative, we got a positive number, which is 60. That's why they're saying greater than 0. Therefore, over this interval, this function is increasing. Am I making sense?
Yes, sir. Thank you for explaining.
But then, where we are now, it is no longer, we are only using the first derivative to get what? The critical values. And then we use the second derivative to see where our graph is concave up and concave down. The second derivative, second, eh?
Yes,
You
sir.
with me?
Yes, I'm with you.
We are now using the second derivative. Mr. Manja, we were done in terms of where the function is increasing and where is decreasing. Né? You remember? Mr. Manja, you still here? Is he gone? Oh,
Yes, sir, he had to drop off.
sorry? He left.
Yes.
Okay. Zwanga, where is this function concave down and where is it concave up?
I said it's concave down at negative 12 and concave up at positive 12.
Nga?
Excellent.
Please repeat. Over which interval is the function
Oh,
concave down? Over which interval is the function concave up?
concave up at 2 and negative 16. I think I might be wrong with this one. No, concave down at 2. Yeah, at 2 and negative 16, and then concave up at negative 2 and 16. I stand to be corrected.
Slowly. Looking at this curve of mine now. Please repeat what you said, my sister.
Concave down at 2 and negative 16.
Here is my question. Over which interval interval? Is the function concave down? And over which interval is it concave up?
I think I might not be understanding properly, so I need some help with that.
Okay, no problem. Help me out here. Let's say you have got the Cartesian plane. Eh? Did you draw this graph?
No, I just have all the values that I.
Oh, you just have the values.
Yes.
Right. Don't worry. Now, remember, we have got this number. We have got this point, 2 and negative 16, eh? Where x is 2,
Yes.
where x is 2, y is negative 16. Please plot that point.
Yeah.
Have you got it?
Just drawing my graph. Okay, I've plotted those points.
One of the points is x equals to 2 and y is negative 16. Eh?
Mm-hmm.
Another one is x is negative 2 and y is positive 16. Eh?
Yes.
Another one is the inflection point at the origin, 0 and 0. Eh?
Mm-hmm. Yes.
Now, we said, I'll tell you what we said. Tell you from what Mandla said. From negative infinity to negative 2, this function is increasing, meaning this curve from the left is going up to that point of minus 2 and 16. We agree?
Yes.
From the left is going from down below the negative x-axis is going up to that point of where x is negative 2 and y is positive 16.
Yes.
Are you there? Have you got that point?
Yes.
Then the next point that we need is the origin.
Mm-hmm.
Now you are moving, you are drawing. Now you are moving from that point of minus 2 to the origin. You are coming down. Okay?
Yes.
Now you rest at the origin. Okay? Then the next point is
2 and negative 16.
2 and negative 16. Now you plot that point, then is then that you are now moving from the origin to that point. Okay? Have you moved from the origin to the point 2 and negative 16?
Yes, I have.
Okay. Then from that point, this curve is going up.
Mm.
Do we agree?
Yes, sir.
Thanks. Ms. T, I don't know whether, Ms. T. Ramponi, are you here?
Yes, sir. I'm still here.
Okay. Thank you, my sister, for being here. Did you follow how we drew this curve?
Yes, I followed.
Sorry?
I followed.
Are you sure?
Yes, sir.
Then, if you followed, then what we have been saying, what we said about the curve being concave up, concave down, and then of the interval where the function is increasing and decreasing, it should make sense.
It's making
All
sense.
that, sorry?
It does make sense. Thank you, sir.
Thank you. Thank you. It should make sense because it follows. It guides you. how the curve should be drawn. Please, this is what we'll focus on today. Number 11. Do you see number 11?
Yes, sir.
11. How many minutes do you need to work out number 11?
Well, I don't know.
You don't know. Okay, talk amongst yourselves. T. Ramboni and Zwanga. T. Ramboni, please talk to Zwanga. There is also Kariso here. Kariso, Lufafa, please talk to us. Kariso. Yeah, okay. T. Ramboni and Zwanga, please agree on the minutes that you are allocating to workout number 11.
Say 5 minutes?
Minutes is enough.
6 is fine.
Sorry? What are you agreeing on?
6 minutes.
6. Okay. All right. Then you have got 6 minutes.
Good answer.
Thank you. Now, where should I start? Okay, is this one. What did you get as the critical values? We're working out number 11. F of x equals to 3x cubed minus 36x minus 3. What did you get as the critical values?
I
Members?
got 2 and negative 2.
2 and negative 2. We are in agreement. My next question. What are the corresponding y values for 2 and negative 2? What are the corresponding y values, numbers? Tiramboni?
Yes, sir.
Yes. Do you agree that the critical values are 2 and negative 2?
Yes, I agree.
Yes. Now, what are the corresponding y values? Anela, yes, I'll talk to you after talking to Ms. Tiramboni.
So I got f of 2 is negative 51.
And f of negative 2?
45.
I also agree. Zwanga, do you also agree?
Yes, sir.
Thank you. Now, what did you get, let me see, as an inflection point? Anele, what did you get as an inflection point?
So I got 0 and 0.
Inflection point, you got it as 0 and 0.
Yes, sir.
Let me reserve my comment. Kariso, your hand, I see you. Please go ahead. Kariso? Kariso? Kariso, please unmute and talk. Kariso? Kaizo just raised his hand and is not talking. Okay. Now, okay, that's Anele. I heard you said an inflection point is at 0 and 0. Ne? Anele, that's what you said.
Yes, sir.
Okay. I'm reserving my comment on that one. Let me go to Mr. Ramponi and Zwanga. Zwanga, Mr. Ramponi, what is an inflection point?
I also got 0.
Zwanga, you got 0 and 0. Mr. Ramponi, what did you get?
0 and -3.
Please tell them.
I got 0 and -3.
Anele. Thank you, Mr. Ramponi. Anele. Anele.
Yes, sir.
And Zwanga. Please explain to us, how did you get 0 and 0 as an inflection point?
So I made an error while substituting f of 0, sir.
Okay. Zwanga?
Same, I didn't go further. Same mistake that Anila made.
Okay. Mr. Ramponi, please explain to us how you got an inflection point to be 0 and -3.
I calculated the value of, I first got the second derivative and then I equated it to 0. After that, I substituted the 0 into the original formula, which is f of x equals 3x cubed minus 36x minus 3. And I got the coordinates to be 0 and -3.
Okay. Anele and Zwanga, did you get that?
Sir.
Thank you. Now, my next question is, let me start in this way. What are the intervals? What are the intervals? You need this for you to can be able to draw that table of signs. That table of signs is very important. What are the intervals? Family members,
Can I
what
try?
are the... Yes, please.
For the intervals, I got -∞ to -51.
Hang on. I'm looking for intervals. Mr. Ramboni.
Okay. I think I see where I made a mistake.
Is it, can
Sorry,
I also try?
Okay, Zwanga, then followed by Anele.
Is it not negative
Intervals?
infinity to -2?
Another one.
Go next.
I agree with the one that you just gave. Another one. Okay. Anele? Another interval?
So for decreasing, I got the absolute value of x must be less than 2.
Hang on, Anele. You are now confusing me. I'm first of all looking for the intervals. Once I have my intervals, everything will fall into places. Everything will just follow. Once I've got my intervals.
Sir,
Yes.
for
Yes.
increase, sir, I got absolute value for increasing, sir. Is that the interval we're looking for? Or all intervals?
Okay. Anele, my brother, let me help you in this way.
Yes, sir.
What are the critical values?
2 and minus 2, sir.
Thank you. From the critical values, then we form the intervals.
We know that f of x will increase when the absolute value of x is bigger than 2, sir.
I'm not denying that, but my question is straightforward. It's not looking for that. Mr. Ramponi,
Yes, sir.
I'm looking for the intervals.
Sir, I fixed my mistake. Can I try
Yes.
again?
Yes, please.
So it's from negative infinity up to negative 2. And
I
then from
agree.
negative
The next
2
one,
up to from negative 2 up to 2.
I agree.
And then from 2 to positive infinity.
Thank you. Just wait there. Anel, did you get that?
Yes, sir, I got it, sir.
That is what I was looking for. Once you have got your intervals, then everything will just follow. Then these intervals will then help you to can be able to draw that table of signs. Then that table of signs will show you where the graph is increasing and where is decreasing. The table of signs, in addition, will show you where the graph is concave up and where is concave down. Okay. Now, let me go to Ms. Tiramboni. Tiramboni,
Yes, sir.
please, let's talk. Where is this function increasing? Over which intervals?
From the interval negative infinity up to negative 2, and also from the interval 2 up to infinity.
Hang on. Please repeat. The function is increasing over which interval?
Negative 2, from negative infinity up to negative 2. And from 2 up to positive infinity.
I'm in agreement. Then, where is this function then decreasing?
From negative 2 up to 2.
Thank you. Next question. Where is this function concave down? Over which interval?
I haven't drawn the graph yet because I was fixing my mistake.
Okay.
But let me
Anele,
try.
okay, fix the mistake while I'm talking to Anele. Yes, my brother.
So would I be correct to say that f of x would be concave down for x less than 0 and concave up for x greater than 0?
My brother, I hear you, but we need this thing, we need what you are saying in terms of the intervals.
So, okay, so can I ask, will I be penalized in the exam if I use an inequality instead of an interval?
Oh, Anel. I haven't got an answer to your question. But what I can just say to you is that you can only be able to tell that a function is concave up or concave down over an interval. Are you with me, my brother? That's why we don't draw that table of signs for nothing. That table of signs shows us where the function is increasing and then where function is concave up or concave down. That table helps us with many things. Anel, my brother, am I making sense? Tiramponi, don't disappear. I'll be with you now. My brother, Anel.
Yes, sir.
Am I making sense?
So I don't understand, sir. If the inequality has the same information as the interval, sir, how is it wrong? I'm confused, sir. Sorry.
Okay, here is my question. Do you get this concept of intervals? Yes or no?
I think I do, so I'm not sure.
From where I'm sitting, I think I can conclude to say you don't follow this concept of intervals. And then it will be difficult for you to draw that table of signs if you don't understand this concept of intervals. I said we draw or we determine the intervals from the critical values. The critical values guide us or instruct us. Those values that we get as the critical values, they tell us what our intervals will be. Mr. Ramponi, your hand was up.
I was gonna give an answer, then I realized that the answer he gave is kind of correct because he's just using inequalities. But I understand how you got the answer.
Okay, Mr. Ramponi, help me out here. The inequalities that Anele is referring to, are they able to help us to draw that table of signs?
I don't think so.
That's why I get worried. That's why I'm worried. Now, are you in a position to share with us where the curve is concave down and where it's concave up?
So should I give the coordinates or the interval?
The interval.
For the x values.
The interval. English is not my mother tongue, but I think we've been using the word interval for some time now.
I don't know, because he said from 0 to negative. Okay, let me just give my answer. It's concave down from negative infinity up to 0, and then it's concave up.
Wait, slowly. That is the interval that I'm looking for. It's concave down where?
From negative infinity up to 0.
Thank you. I agree with it. Next.
And then it's concave up from 0 to negative infinity to positive infinity.
Thank you. That's what I was looking for. Anele, is this making sense?
Yes, sir, it makes sense.
Zwanga,
Yes, sir.
is it making sense the way Ms. Tiramponi explained it?
Yes, sir.
Okay, now this is how this curve will look like. Remember, we have this point where x is 2 and then y is negative 51. X is 2, x is 2, y is negative 51. We agree. If you need to draw it. Because, okay, anyhow, it has to be drawn. One of the points, x is 2, y is negative 51. Are we together? Mr. Hiramponi, you a guy, did you draw
Yes,
this
sir.
graph? Because you can only be able to see that even the graph itself tells you that question, you even see it from the graph. Before even the table of signs confirms it, even the graph itself confirms it. Do we agree, Mr. Hiramponi?
Yes, sir.
The table of signs confirms it. The graph itself. Those points, when you plot them, confirms it. You'll have that point 2, and where x is 2, y is negative 51. You'll have another point, x is negative 2, y is positive 45. And then you will have this inflection point of 0 and negative 3. Then, knowing how the curve is behaving between negative infinity and negative 2, and between negative 2 and positive 2, and between positive 2 and positive infinity. And it becomes easier to draw this graph. Okay, Mr. Hiramponi, this graph is going up to this point, negative 2 and positive 40, positive 45, eh? Do we agree?
Yes, sir.
And from there, it comes down. It goes through 0 and
Negative 3.
negative 3. Comes down to this point of
2 and negative 51.
and from there it goes up. Do we agree?
Yes, sir.
Question from anybody? All right. Please. This was number 11. Please work out number 13, 15. Work out number 13, 15. I will tell you. 13, 15. I said 13, 15. And then the next 7. Okay. Just work out number 27. Let me see, I'll tell you. 13, 15, 27, and 29. Yes. 13, 15, 27, and 29. We'll start by checking them tomorrow.
Sir,
Yes.
sir, I'm confused because the reason why I got the inequalities was I was applying the second derivative test, sir. So if by applying the second derivative test I get like inequalities, must I change the inequalities to intervals or should I just use the sign table?
Let's look at this first example together, okay?
Yes, sir.
F of x is equals to x cubed plus 3x squared minus 9x minus 13. You with me?
Yes, sir.
We have to find the relative extrema of the function f given by this f of x and sketch the graph, right?
Yes,
How
sir.
do we do that? We get the first derivative and we also get the second derivative. But we put the first derivative to be equals to 0, okay?
Yes, sir.
Then we solve for x values. The x values are minus 3 and 1. Clear?
Yes, sir. I'm clear on that.
Then from there, we get the corresponding values by substituting in the original equation, okay?
Yes, sir.
So f of 3, they got 14. F of 1, they got negative 18. The next thing that they then did was to calculate the second derivative of what? Of the critical values. Using this theorem. See this theorem of the second derivative test.
Yes, sir.
Number 1 is saying, if the second derivative of f of c is greater than 0, then we've got what? Relative minimum. In other words, if that number that we get after substituting one of the critical, when we take one of the critical values and then we substitute in the second derivative and then we get a positive number, then we can be able to say that number is our relative minimum. Are we together?
Yes, sir.
Number 2 says, when we substitute one of the critical values in the second derivative and get a negative number, remember a negative number is always less than 0.
Yes, sir.
Then we are saying we are having what? A relative maximum. Are we together there?
Yes, sir.
Now let's go back. Then, remember, the critical values are negative 3 and 1. They substituted minus 3 into the second derivative. Second derivative, which is this. So, they got negative 12. Negative 12 is less than 0. Negative 12 is less than 0. That is why that number is being referred to as relative maximum. This one. Are we together?
Yes, sir.
The next is one of the critical values is 1. When you take 1 and substitute in the second derivative, then they got 12. 12 is greater than 0. When 12 is greater than 0, The second derivative, when you substitute a critical value in the second derivative, you get a positive number. That means that number is greater than 0. Then you've got the relative minimum. That's why they are saying this. Are you with me?
I agree, sir.
Next, the next thing that they need then from these critical values, remember our critical values are -3 and +1. Oh, okay. They didn't do it here because we did it in the first derivative. In the first derivative. So the interval, you will have 3 intervals. The first interval will be formed by -∞ and -3. Okay?
Yes,
Okay.
I agree, sir.
Okay, let me not confuse you. This is where this thing is coming from. But in this case, remember, that is a continuation. In this case, we're only talking about the first derivative. Please don't get confused. Né?
Yes, sir.
So first, from this function, this is the function. Get the first derivative. Put the first derivative to be equals to 0. Get the critical values. Critical values are -1 and 2. Okay? From these critical values, then form the intervals. The intervals are -∞ and -1. Another interval is -1 and 2. This one. Another one is +2 and infinity. Are you still with me?
Yes, I'm still with you, sir.
That's where your problem is. I have noticed you are challenged. Here is where your challenge is. Then, what you then do, you don't get confused. In that case, it will be the second derivative. In this case, is the first derivative. What you then do, you choose a point over this interval between -∞ and -1. Okay? You choose one value, a number that is between -1 and 2. You choose a number that between 2 and +∞. So between -∞ and -1, they chose -2. Okay? And they chose -2 and they substituted it into the first derivative. They got +24. This one. Okay?
Yes, sir.
Is greater than 0. That's why they are saying when we substitute -2 into the first derivative, we get a number that is greater than 0. They are referring to this 24.
Yes, sir.
If we substitute one of the critical values into the first derivative and then we get a number that is greater than 0, therefore the function is increasing over this interval. Then another interval is -1 and 2. Then they chose a number between -1 and 2. They chose 0. And substituted where? In the first derivative. Here. That's what they did. And then what did they get? They got -12. -12, which is less than 0. Then they say, okay, when we substitute 0 in the first derivative, we get a number that is less than 0. Which is, they're referring to this -12. Are we together?
Yes, sir.
If this number is less than 0, therefore, how do we conclude? The function is decreasing over this interval. Finally, on the interval, +2 and +∞, they chose what? They chose 4. So they substituted 4 in the first derivative, and then they got +60. +60 is greater than 0. That's why they come here, they say, when we substitute 4 in the first derivative, we get a number that is greater than 0. They are referring to that 60. Therefore, if we got a number that is positive, then we conclude by saying f is increasing over this interval. So this table that even in the first derivative, you'll need to draw this table. Then you won't get confused when I say over which interval is the function increasing or function decreasing? Over which interval is the function concave up or concave down? You won't be confused. Are we clear?
If I understand you correctly, sir, by looking for the intervals, we are looking for whether the function is increasing or decreasing on certain intervals, and we want to list them.
Yes.
So wouldn't it be faster, sir, to try and use the test for concavity combined with the second derivative test to just get the function's shape and then conclude based on the graph?
I hear you. That is what, remember, in this case, they were only using the first derivative. I brought you here to show you the idea of using this table of signs. So even in the second derivative test, you can use the very same table, but they are not showing it. But then even if they didn't show it, you can do it and then be able to conclude. Whether you do it or you don't do it, but the most important thing, you should be able to tell me the interval over which the function is increasing or decreasing.
Thank you, sir.
Are we together?
Yes, I think I understand now.
Okay.
Thank you so much, sir.
Thank you. You're welcome. Any question from anybody? All right. On that note, then, please, may we then agree that we'll see each other tomorrow at, my sister, I think, is at 1 tomorrow, no?
Good evening, guys. Thank you, my brother.